So welcome everybody to this workshop on Scientific Visualization 101, an introductory hands-on workshop with Amira and Avizo. My name is Thomas Teusel from the KAUST Visualization Core Lab. So to get you started, when you registered, you should have received an email, registration email with all these links, but I've put them here on the slide again. The most important link is the first one on top. The starting point, all the materials, all the information is on this link. Make sure that you open this in a tab and have it handy. The second one is we provide more training, different trainings, and you get a overview of this training also on this webpage. And the specific link is here, a second link. And thirdly, we have the material for today, data sets and slides. These slides, you can download them for your later reference and convenience, and download the data set. Also, we are recording this workshop, so it will be online afterwards. And we have recorded other workshops, which you can find at our YouTube channel. Just check them out. Before we start, I just wanted to give a quick overview of the data set we're going to use. So I was trying to find one that's of some relevance to the community here, and this is a data set provided by Jamal Al-Amri from NPERC, the Al-Naimi Petroleum Engineering Research Center here at KAUST. So it's an actual real-world data set that we're using here, and it's a mini core plug which is isolated inside a shrink tube, which with a rock that represents a kind of a sandstone that's found in oil and gas reservoirs. So that's come in, just take a seat. So that's very relevant for these people doing this research. The data set consists essentially of 466 images that make the slices of your data. You see one of the images here. These slices are stacked on top of each other and make up a 3D volume which describes your data. And you see two examples. And also that's what we're going to do later on in the hands-on sessions. What that looks like. So you get an idea of what the thing looks like in 3D. This is the actual physical object. And the data, the way it's given, is in these kind of slices where you see the rocks. Also, it's as 2D slices. So this is a data set we're going to work on. Download it. I'm going to show you later again to make sure how to do this. But if you have time right now, just download the data set. This is the one we're going to use. For this workshop, you're going to need Avizo or Amira. This is the same. If you're here at KAUST, you can download it from the IT web page. This link here, though, is dangerous because the latest version does not work yet. And on the web page, the latest, that might link to the latest version. I think my colleague Ronel is posting a link to a working Avizo version right now to the chat. So if you have not installed Avizo yet, you can use these first 2 minutes of this short presentation introduction I give to install actually Avizo. And if it doesn't work at all, you can always try to get help from IT. That will not help you for this workshop, I guess, but they are actually responsible for you to get it running. If you want to use Avizo and Amira, then we are the right people to talk to. So whenever you have a problem in using it, so it runs and you can load your data, but you need more, you don't know exactly what to do, there's expertise in our lab. Just get in touch with us at help@vis.kaust.edu/USA. And if you have any question. So before we start the workshop, I just want to give you a quick overview of what we do here at KAUST and what we are there for, the Visualization Core Lab. So we are a small lab inside the core labs. The core labs is a kind of a support layer for the university to support all kinds of research. And we are here to support you researchers, students, postdocs, with all kinds of visualizations, looking at your data in a visual form. And we have a small team, we have 6 people. We have our lead is an expert in visual analytics, information visualization, statistical analysis. We have 2 scientific visualization people, so these kind of things that we're going to do today. That's myself, and this is James. Then Ronel is an expert in virtual reality and augmented reality for visualization, and also in 3D reconstruction, also something that we do today. Today it will be an introductory course. If you need more advanced things, Ronel is doing more courses on that, and they are actually also online, you can watch. And then we have two data scientists, machine learning, deep learning. So if you need help with work in this area, you can also get in touch with us. So what we do is, in principle, is we do three different things. So we have certain visualization hardware that we support and that we maintain, also for people at KAUST to use. We work with people on their data visualization workflows and their individual problems up to availability as much as we can. And since that's probably not everyone, so we probably cannot serve anyone that way, so we also try to. We do a lot of trainings and workshops like this one, which are recorded, put on our YouTube channel. And here you have again that link to the YouTube channel, just check it out. This is a quick picture of what it looks, what the visualization work core lab actually provides and what it looks like. So we have the big picture on the bottom is our big display wall, which you can use for big displays, for maybe even streaming and having meetings with other people where you need lots of space. So you can use that for that. We have virtual reality installations like the cubes, where you can look at the data in 3D, but also head-mounted displays, several of them trying to stay up to date with the new developments. And we have something which might be interesting for people doing the kind of things that we're doing today, segmentation tablets, which are specialized for doing more complex segmentation work than what we're going to do today. An introductory workshop, we do a simple example just to get you started. If this is not good enough for the workflows you have, for the problem you have, we could also use our segmentation tablets. If you're at KAUST, this is only relevant for the people inside KAUST. You can always book these facilities. You just go to our webpage booking, and then you need your KAUST portal credentials to log in, and you can check any of our spaces and book them for a certain time. Usually, one of us will get in touch with you if you need something, if we can help you, and then you can just use. And again, if you're not sure what to do, what to use, if it's relevant or useful for you, just send us an email at this email address. Just a quick overview. This is our webpage. Check it out, wiki.vis/KAUST/edu/USA, to find all the information on what we do, what we provide on all our workshops, all our training, how to contact us, where we are on this webpage. And I just wanted to point out again that we do quite some training events, so you find them on our wiki. Those trainings that are upcoming, and also the previous ones, and most of them, a lot of them, especially the later ones, are on YouTube recorded. We have essentially three different tracks, one on scientific visualization, like this one, for Avizo and Amira, but we also do it for ParaView and Visit, which are similar tools, but they're open source, focusing on slightly different things. So you might, if you have a certain visualization problem, you want to look at your data in different ways, you might also check out those workshops. We have a series of data science workshops where you learn everything that you need in your data science workflows, from Shell, Conda, Python, Git, and these things. So if you don't know about those, or if you need to brush up on some things, check those tutorials out. And then more specialized and more advanced, we have AI tools and techniques workshops series on machine learning, deep learning, and visualization, but data science and these kind of things. Again, if you need this, if you need AI tools these days, probably a good idea, just check that out. Okay, this was a quick introduction to the lab, and so that you know what we do and what we're here for. I just want to point out again, if you have questions, any problem, especially with the tools that we support, just shoot us an email anytime. One of us will get in touch with you. For today, so then let's get to what we're going to do today. So this is a workshop, introductory workshop. What are the goals and the agenda? First of all, this will be a completely hands-on learning with Avizo and Amira. So ideally, you have a laptop, or if you want to follow the hands-on sessions, you should have a laptop. either with Windows or Linux. Avizo does not run on, it's not supported on Mac. And it is completely introductory, so if you have not heard anything about Avizo, this is the perfect course for you. And after these first few slides, I'll just show things with Avizo, just a hands-on session, interactive session. And we should have plenty of time to discuss things, to ask questions. The second thing is, what I want to talk about here is a quick history about Avizo and Amira. First of all, there might sometimes there's some confusion. Is it Avizo? Is it Amira? What's the difference? So there's a short history on where these came from. The point is that, so first of all, it's a commercially supported visualization tool for 3D and 4D data visualization, processing and analysis. Commercially means you have to pay for it. You need a license. Here at KAUST, we do have that. Those people watching online, they should have a license from their institutions or would have to pay a license. But here at KAUST, we have enough licenses that everyone should be able to run Avizo. If not, let us know, then we will talk to IT. So the name comes from that this visualization tool, the software was started as a research project at the SUSE Institute in Berlin, and they called it Amira. And then another group, a visualization science group in Bordeaux in France, picked it up and started a complementary tool. They waited a little bit from it and they called it Avizo. So these two things were developed in parallel for a while. But 12 years ago, 13 years now, actually, FEI purchased this visualization group and actually started to merge Avizo and Amira back into one tool. And as far as I know, this is done by now. So long story short is that Avizo and Amira are the same thing. I will call it Avizo from now on. I'm in both. And then 2016, FEI actually has been bought by Thermo Fisher, which is now what's developing Avizo and Amira. Just to give you a little overview and what's the name and where the name comes from. And what is it used for? So these are some of the main application scenarios that you might have with Avizo. This is a slightly older slide, so it's actually distinguishing between Avizo and Amira. As I said, these days it should be the same. But you can use it for things, typical workflows in life sciences, where you take electron microscope images, for example, from tissues, from cells, small things. It's also used for the natural sciences, often CT scans. In this case, it's a head of an animal, and you have been segmenting, looking at the teeth. You can use it in materials science and materials research to analyze your materials, to find properties. And one more applied application could be in industrial inspection, where you're building some kind of mechanical parts. You put it in a CT scanner, and then you can investigate it without actually destroying it. So this is the idea of what Avizo is good to, therefore, for visualizing, for analyzing, and is in the end for understanding your data. And this is a typical workflow of what also what we're going to do today, just parts of it, of course, because you already have the data, but this might be what your workflow, if you're thinking about using Avizo, is like. It starts with some data acquisition. You usually have a CT scanner, an electron microscope, not you yourself probably, but your institution, and they produce some kind of data, right? Then you have to import this into some tool, in our case into Avizo. That's what we're going to do today. You most likely, it might not be already in the form that you need, so you do some filtering and pre-processing. We can skip this step today because the data is already the way we want. Then a good thing to start with is to do some visualization at that point. Before you do any analyzing or measurements or stuff, just take a look. The human visual system is very good at understanding and seeing things which algorithms might miss, right? So just take a look. That's what the visualization is there for, to see and make sure that your data is what you're expecting, or maybe find something interesting that way. And then probably the most important step for many people these days is that you have to do some segmentation. So you want to find actual structures in your data. That means you want to assign certain labels to certain areas in your data set, which is one structure. For example, this image, and that's what we're going to do today, a rock sample where you have grains, and you want to segment the individual grains into individual objects. That's a difficult thing. We're going to only touch on this today, but it's something that Avizo has lots of techniques and algorithms available that you can use. And then, when you have done that, you then can start with doing your measurements and analysis, like counting objects, measuring their sizes, or surface areas, whatever, statistical properties, and then probably you want to use this for doing some presentations. Present your thesis, apply for a grant or whatever. That's also what Avizo can help you with. The presentation you will most likely do with some other software, but you can export images, spreadsheets, generate your numbers that support whatever research you've done. Okay, so this again, this is a typical workflow, and we're gonna essentially today we're gonna import the data, we load this, we're gonna visualize it, and we're gonna segment it in a simple way, and you'll see if you get that far that these simple techniques are actually probably not good enough. So again, I want to point out that we have workshops on more advanced techniques in segmentation. Good. And this is a little bit of a timeline, what we're going to do today after this introduction, 10 minutes, already a bit over that. We're going to start with what I call the scientific visualization of scalar fields. Scalar field means it's just one number, like a density. That's what we have. And we're going to look at simple techniques there. We have plenty of breaks. We'll even have a break in between this one session, because afterwards, then we're going to do a session on volume segmentation. Again, with plenty of breaks in between, so we can discuss things. And if there's time, I can show a few things that I think are important about Avizo in general, but most of them I will show while we're going anyway. And then in the end, we can have a short QA and discussion. All depend on how much time. There's no fixed plan for me. I'm just trying to go through this, and let's see how far we get. And if you have questions, just ask anytime, okay? And again, this is a data set we're going to use. That's what we're going to do. Scalar field visualization, meaning we're going to slice through the data. We'll do some recasting and volume rendering to get these nice 3D images. Also interactively, you can then rotate and look at all angles. And we do some volume segmentation, two simple techniques, very simple thresholding, one a bit more advanced, watershed. And as I said, this is probably not good enough, not even for this data set. You might want to then use the segmentation editor, which is a good tool within Avizo to do more advanced segmentation, but we're not going to touch on this today. This is done in this advanced workshop. All right, this is now where we start. I start switching to my other laptop over here. Give me a second. There we go. Okay. So first of all, I wanted to show you again our web page. Make sure you, if you just go to our wiki about anything, should look like that. Then you have the training events on the left, and the link to all upcoming trainings that you can take a look at. And the one you're in is today, January 26, Amira and Avizo. Click that. You should also have received the link in an email. Get directly to this web page. First of all, similar workshop like this, I've recorded one and put it on YouTube. You can just take a look at that. So if some things are maybe a bit too fast or you missed today, you can just take a look at that recording. It's probably a good thing to download also the slides so that you have something for reference, and definitely download this data set. If you do that, just a quick pitfall here on Windows. It might look like that for you, like it does here for me. In my downloads folder, you get your data set, which is, however, not yet uncompressed. It's still a zip file. It doesn't show on Windows. I don't like that, but it just shows the folder. The icon is slightly different. So you still have to uncompress that, otherwise Avizo won't find it. So just right-click it and find the extract all. It might look slightly different depending on what kind of Windows you use, but you should have some kind of extraction. Set extract all and then extract. Takes a few seconds, and you should have in the same folder, and now it even opens a new window with that, with your data set, okay? And if you look at the data set, as I said, the data set is just a collection of images, 266 images. And we're going to take a quick look at how to load this in Avizo after the break, before we do a quick break, so we can make sure that everyone is up to speed. I just want to make sure, so everyone who wants to follow, start Avizo, and I'm using version 2023.1. I hope you find some that works for you. If you started, it should look like that. The opening and welcome screen of Avizo, and we'll make a short break. I'll take a look around, and people online, you can go back in the stream, by the way, and watch things again, and just reload the page when you want to come back. We'll be back in 10 minutes. All right, everybody, welcome back. So I hope everyone who's watching now also managed to start the Avizo, and it looks something like this for you. Of course, you're also welcome to just watch and see if that's something that you can need. So I'm just going to demonstrate a few things now. We start easy. The first part is we have this data. We got it from a. Can I actually go there again? Yes. We got it from, in this case, from a CT scanner. Someone did the scan for us and provided us with this data set and wants us to visualize it now or take a look, segment it, analyze it. The first thing is we want to import it into Avizo. The simplest thing here is to just, on this welcome screen, press Open Data, opens a panel, and I make sure you know where you saved or downloaded your data set. I left it in downloads. I go into the folder. And here are the files. Now I want the whole data set, so I have to give all these files to Avizo. The simplest thing to do is select one, press Ctrl A to select all of them, and then just say open. Then another dialog opens, and you should just make sure to check that everything works right. It says here again that we have 466 files, slices. These things are not so important. What the name is, we can already specify a unit that our numbers that we put in are in. It's in micrometer. This is actually, for this case, exactly what we want. We could choose different ones. If in your case something different is selected, you might want to select micrometers here. Because we have to give, so these are just images. Avizo has to know what is the pixel size of the image in actual physical units, like micrometers. And that's something you have to know. That's when you do the scan, whoever does the scan should know, because the scanner has certain settings, and then you should know. And in this case, I know that 1 pixel. That's why we leave the how to define our size now, our resolution. We leave it at the voxel size, and know that our voxels have dimensions of 14.6397 micrometers in X direction, the same in Y direction, and 14.63 only in Z direction. So meaning that the images have a certain width between pixels, and the slices, interslice distance is also a certain number, in our case 14.63 micrometers. Again, if you don't have that information, you can still load it, but your measurements might be wrong. The numbers that you then get don't really correspond to what actually your data set represents, so you should get these numbers from whoever provided you with the data set, okay? And then just press OK. Don't check this read as multiple files. We want it as one data set. Just press OK. Now Avizo loads this data set. This default layout in my case looks horrible. I'm gonna delete a few. That's what it should look like for you. If you have additional windows open, just delete them like I just did. Also here, the default layout here is a bit, I'm going to explain it a bit later too, but press this button here to make your layout over here a bit nicer. So what are you seeing? So Avizo loaded a data set, and it has here, which is called the project view. It represents your data and your visualization workflow, your display modules, and what you want to do with your data. We don't have much things here. It should look like this for you too. You have one module here in green. Green for Avizo means this is a source of the data. If we click this, you have the properties panel down here. I can make that a bit larger because we don't need so much space here at the moment. And that's the one thing I always do at the beginning. When you load your data, you select it here and you make sure that everything went well, and it looks like that's actually your data, right? So again, this is the important thing for me as a computer scientist. Our resolution of the data we have is 742 by 742. This is the pixels of one image per slice, and then we have 466 slices. So you can double check that everything has been read in correctly. It's also good to know that it's a grayscale image, so it has only one value per voxel, and these values are represented in this case only per 8-bit. Which is not that much, but it's good enough for what we do, and often you even have float or double values here. Okay, You have a little bit of information how much memory it took. That might be interesting if you have large data sets to see if you have a problem. Make sure you have enough memory to actually load your data sets. But 250 megabytes isn't a problem even on this laptop. And then here you already see why it's important to put in the correct numbers and units in when you load the data, because now you see that you have that your data set, that your sample is actually these numbers of micrometers large, right? So 10,848 micrometers in each site, and a little and only 6,800 high. And you have a little preview of your data set here of one slice. One feature of Avizo is that it automatically already attaches a display module so that you see something. So you should have this auto slice already here, which is attached to your data set. Okay, that means this auto slice actually visualizes this data set. If you don't have it or if you don't like it, you can select it and press delete, or on this laptop at least, or just drag it over this trash icon here. Then it's gone, then you don't see anything anymore. Could be because not all of Avizo versions have this default feature. So if you only see this data set with nothing else, to bring up this, to attach them, that's what called we are attaching a module to your data that does then some displaying. You press this little arrow button here, which brings up a menu, and then you just, there are lots of different things you can do. The nice thing is that all you see here is all the things that you can do to this kind of data. There might be different kinds of data which allow different actions that you can do, and you just see those you can actually do with your data. And in display, you should actually have an auto slice here. You select that and press create, and then you're back to this display. So this what now everyone should see. At this point, let me talk a little bit about the interaction now in Avizo. So on the right, this big window is just your display window, right? So you have essentially three important windows here. This one is the project view, where you see your data, where you see what you're going to do to that data, how you display it. Then you have the properties panel, where you see all the properties of whatever you have selected here. So if you select different things, you get the properties of this, whatever is selected. And then you have the big display panel here with a lot of buttons. We're not going to go through all of them, but some of them are so interesting. So if you press this magnifying glass, you can actually zoom in and out of your data set just to see. So you see the individual rocks, and you see also the further you scroll in, zoom in, that these are at some point made up of only of pixels, right? That's one thing. If this is a pen thing, so if you select this one, you can just move it around. And if you go back to the hand, this is actually rotating. And this is actually interesting because although it's just a slice, you see that this already it's still a 3D visualization. The slice is somehow situated in space, and you can just rotate it around. What's doesn't work? Okay, panning works with the middle mouse button here, but zooming does not really work. Let's zoom out a little. What you don't see in this display is what your data, how large your data actually is. So one thing I often like to do is see where my data actually is given is what's called a bounding box. It's, if you go again, press this little white arrow here. It's actually already in favorites. That's convenient. You select the bounding box and say create. So now you see in this little box where your data is actually, the whole box is your sample of data that you have, and you see one slice in between, okay? To illustrate that, go to the auto slice. So here you can actually select the slice number you want to display. We are displaying slice number 233, but I can just drag these slice numbers around and look at different slices, and you see that in the 3D display, this goes up and down because that's where the slice is. And you can also imagine already what this core plug looks like with the rock samples in between. Okay, that's one thing. If you want this simple ortho slice, that's why it's called an ortho slice, provides just three different orientations for the slice. You can slice in X, Y direction, what we do here, or in XZ direction. Avizo will always automatically zoom into that view so that you see that slice nicely, but you can then again rotate around And now you see the sample from the side. Okay. So you can also scroll through now in this direction. The nice thing about this project view is that that you can attach things as many as you want, but whatever is interesting for you. So, for example, I want to see now the two different slices because I might want to see them in X, Y, and in XZ direction. I can just attach the second author slice to here, right? Avizo, by the way, remembers those modules you have used recently over here, so you can just reuse that button to an author slice. Now get a second author slice here, which I again can orient and look at in arbitrary wherever I want. Can also do it like this and move it around and look at these different views of what your sample looks like. If I go back to XYZ, that's sometimes really useful to understand a little bit better what your data set looks like. All right. Move it up here, zoom out a little. What else do we have in the what? So this author slice is a rather simple but very convenient tool to just look at your data in slices. You can just choose a few more different things like a column map here. In Edit, you can choose different column maps for your slice. Usually for this kind of data, the grayscale is actually the best one because that shows essentially what you do. And I think that's about what you can do in a slice view and get a first idea of what your data set looks like. Okay. I will look around again a little bit and talk to people here online. You can try to play around now with these author slides and these modules. Try attaching a few, try deleting some, and we'll be back in after the break. All right, welcome back, everybody. So we'll continue looking at our data set a little bit. I'll show another quick technique to look at your data. And so far, we have only looked at slices. And they give you some information, but if you look at it, you only see, of course, parts, only one slice. You don't see all the rest. You can imagine it maybe, but you're never sure. But there are a few things in Avizo you can do to get a nice overview of what you can do, of what your data looks like actually in 3D. To do that, there are a few options now we can do. So first of all, I don't want to see the slices anymore. I could just delete them again, but there's actually a nice option in Avizo that you can just turn them off. And these are these little blue icons here. They are also even smaller here. I like to use those a bit bigger. If you click that one, it just turns things on and off. Okay, so click it to turn it on, click it to turn it off. Select the other ortho slice, click it to turn it off. I keep the bounding box for now. Could also turn it off and on, but that's also nice. Always nice to know where your data is. So I'm gonna keep that. And let's try to look at some 3D visualization techniques. And there is actually a few nice and easy to use things just to get an overview of what your data looks in 3D. So again, you click this little triangle here, and you go to display. And if you scroll down to the end, you have two modules that are called VolRen and volume rendering. They do similar things. We're going to take a quick look at both of them. I'll start with VolRen and call it create. And you see something. Doesn't look impressive. The first thing is that for some reason Avizo chose a column map, which I'm not sure why, but we can change that easily again. I think for this kind of data, the grayscale is actually the best one. And what you see is it looks like what the rocks are inside the plug. You might not be sure. The nice thing is we cannot only turn off things individually, but we can also mix those things. So if you want to get an idea of what your volume rendering shows with relation to a slice, so obviously these things are the rocks inside this core, right? We move up here. And that's the default view of what this volume rendering, VolRen module does. But you have a few options here. You select it. The one that's selected here, so you have these different modes. It's called VRT, volume rendering, and T stands for texture, which is a technical detail which is not that important right now. It just means it's rendered on your graphics card and it's nice and fast. But that's what it looks like, and you can try playing around. So you can, for example, you have this little widget here actually controls what you see. You see these little lines here that show you actually which part of your data you actually want to see, and there are also the numbers here represent the lower end and the upper end. 255 is our maximum, so we see everything that's up to 255, but we don't see anything that's below 32. Some internal algorithm of Avizo obviously computed this 32, saying this is a nice cutoff here, because if we just drag this to the very left, and we go negative, it makes no sense because we don't have negative numbers, but we have up to 0. We can even type it in. You see that you are actually seeing all this stuff around your data sample, which is just air, and the air has low values, and you actually don't really want to see that. That's why Avizo said, okay, something a bit higher is probably better, but in my opinion, 32 is in this case a bit too much. If we try 17, for example, you also see somewhat the core plug around your data set. That actually, in my opinion, already shows quite nicely what your data set looks like. You have this plug around and the rocks and sand grains in that plug. But it doesn't look that impressive actually. So there are a few things we can change. Shading is a technique that you put light into your scene, and that's probably makes it a bit nicer. Actually, in this case, it made it almost worse, but we want to make it specular, so that looks probably a bit better. You can zoom in, and you see, oops, now I want to rotate. You see your rock samples inside the core. Okay, so that's one simple thing, and you can play around a little bit with the options. That's, by the way, probably a good place to mention that Avizo has actually quite extensive help and the documentation, and it's pretty useful. And whenever you use some module and you don't really not quite sure what it does, you can always press this little question mark here, which brings up a help. Oh, didn't want to dock it. Now it's the large. Oh, come on, go. So it brings up this little window, and which describes first a little bit what it does, and then really in detail, even with few pictures, shows you exactly what all the controls do, and gives you an idea of what you can do with those with these modules. So that's a good plan always to when you use a module for the first time or not quite sure what it does, press the help and read through it. Very helpful. And so I'm not going to go through all these different options that you have here for the volume rendering. I just wanted to point out that there are two options which are super easy to use and give you a quick overview of what your data looks like. And the one is called DRR, which, as far as I remember, stands for digitally reconstructed radiograph, meaning essentially just an X-ray or an X-ray. So like when you do an X-ray at your dentist, with the difference is that you can now interactively rotate it around, and you can actually there are almost no options to set, so you get what you see is what you get, and it just gives a quick overview as an X-ray what your data looks like. In this case, let me turn off the bounding box now. It also just nicely shows what the rock inside this plug. To understand what your data is, what it looks like, and the other option that's also quite nice and even looks a bit better in this case, but it's a bit more difficult to explain, is called MIP, maximum intensity projection, which essentially just computes the maximum value. If you imagine your eye is shooting out rays going through the data set, you just look at the maximum intensity you find along each ray and then plot this at this pixel, and that's essentially what it looks like then. And it usually and often gives you, without any parameters, nothing to change, just a nice overview of what your data set looks like. All right. So these are a few easy techniques to look at your data. Like slicing, slice through it. You can, again, always combine all of those. Might not look great, well, but it does actually also look correct. So you see what the original data in a slice looks like and what the volume rendering does with it. We had the slicing. We have a few different things of volume rendering. We have another module, volume rendering. Forgot that. So we had these two different. Let me turn this one off now too. We had these two different volume rendering modules, volren and volume rendering. There's also this volume rendering module, and it does something quite similar. It looks a bit better, more 3D now. So this almost looks like a nice 3D rendering of your data. There are not many options here you can do, but again, we have this window that we can change so that we go from the rocks only to the block. So now we see the whole block. And if you would go down completely to zero, we'd see another block, which is not useful. So somewhere here, you can play around and find a good visualization and see what's in your data. So the question is, which one to use, volren or volume rendering? I think volren is with these two options, DRR and MIP, just easier to use. If you want more specialized things in volume rendering, You can read through the help what it exactly does and all the parameters you can set and how to change it. And if you go to the help, you also find here a note that compares these two different modules, vol-ren and volume rendering. You have a whole table of, so there was even another volume rendering module which is not deprecated, but you have these two volume rendering modules and what each can do. And if you are into volume rendering and want to see and find out more of that, take a look at this table and this web page and see what all the different options are that you have. So the options we have so far are, as I said, slicing through your data, using a few different volume rendering modules to see what the data looks like in 3D. So we can now hope we understand quickly, quite nicely now what the data set looks like, but that's not the end of the story. What we want to do is we want to analyze this data set now a little bit, right? So in this case, probably a good question of what you want to do is you want to separate these rocks from everything else, from the tube and from the air around. And once you have that, then you can ask different questions like what's the volume of the rocks compared to the whole volume? What's the surface area, kind of porosity or fraction of rock to air, and things like that. For that, what you have to do is what's called segmentation, and that's what we're going to look at a few simple techniques right after the break again. All right, welcome back, everybody. So we have visualized our data set. We have sliced it, we have volume rendered it, and now we want to analyze it a little bit. In order to do that, I'm going to keep all my stuff here. I'm just, again, going to disable things I don't want to see. And actually, let's take a quick look at the auto slice. Let's align it, and let's move in a little bit. So the idea is now you have these rocks inside this tube, and if you look at it, you clearly see the rocks. It might look like an easy task to not just say tell a computer just identify this seems to be a grain, this seems to be a grain, this, and so on, right? Just identify all of them, and then we can do all kinds of analysis, volume, fractions, whatever. Problem is that it's unfortunately not so easy, because if you look a bit closer, it's not a uniform color, right? It's often it's just a noise in there. You have different colors representing one grain, and it's not so easy to say this, and it's also here they overlap a little bit. How do you identify this corner, this boundary? This one is probably even difficult for a human to say, is this a different one? Does it belong to this one? And so on. But that's essentially what you want to do. You want to identify this, in this case, the grains inside this tube, and say, the way to do that is what's called segmentation, and it means you essentially assign a unique number to each pixel inside the grain that's that grain. So instead of these different colors that we have here, we want just one number for all this stuff, and one number for all these, maybe. Actually, we start with a simpler task. We're trying to find one number for everything that is grain, and one number for anything that is this tube, and one number for everything that is the air around. You see that even around in the air, you have different pixel values here. So it's not completely, not everything black or zero. So for example, it's just air. There's more. So we want to identify those, and the way to do this is called segmentation. And there are several ways to do this, even in Avizo, and Avizo is actually a pretty good tool to do that. The simplest one is what's called the thresholding. Some people might not even call it segmentation techniques, but it's definitely used in all of them in some way. And let's just take a quick look at how that works. So the idea is that again, if you look at one of these grains, here you have a low value. This is maybe close to 0, maybe something 10 or 12. Here you have high values. This maybe 200, 220, right? And you say everything above a certain threshold is one material, like grain, and everything else is the other. Like in this case, the air between the grains, and like the air out here, right? And well, let's just do that. There's several ways to do this in Avizo, and the one group of modules we're going to look at now is actually conveniently called image segmentation. So you find a lot of again, a lot of modules in here. We just going to touch on a few of them, but the first and simplest one is actually, again, a subgroup of that, which is called binarization. Binarization means just distinguish between two different materials. And that's what we're going to do. I guess the first one that you want to start with is what's called interactive threshold, because you can actually play around interactively and just see what it does. Let's create one interactive thresholding. If you do that, first of all, you get a red module here. Red means it's actually a compute module, meaning it takes your data and will produce something new. Okay, so far we had only modules for data, which is green. We had display modules, two different ones. Yellow means shows a 3D view of your data, and orange means it just shows a 2D view of your data. Okay? And red means it's a compute module. It will produce some new data. And the way it does that, so we have here, again, quite some options here. And we can now tell Avizo to identify a certain sub-range of the intensities as one object. And it seems that these default values that Avizo found here are already quite useful, because everything that's now blue overlaid in your image here is what we have now identified as grain or rock. And you can change a little bit these thresholds here to see what the thresholding does. That's why it's called thresholding. So everything above 56 is now considered to be rock, and everything, everything between 56 and 255 is considered to be rock, and everything not rock. So you can also drag that down a little bit, but we know that rock got a high value, so I'm going to leave this as 255. If you drag that around, you can try to find, so the higher you get, the fewer structures you will select. So you might want to try to find a good one that goes down here until all of your rock is selected. So this is probably too much already. We already have selected some portions of the plug, right? So 27 is too low. I think 32. There are still some black dots here, blue dots here. So 33 was actually the one that Avizo selected by default. Seems to be a good one. So when you have found a good threshold, which says now separate into two different structures, in our case into rock and everything not rock, you can hit apply. Let's do that. And that's what happened. First of all, nothing changed in the view because we didn't change in the view. What happened is that we got another module here in the project view, which is the result of this interactive thresholding. Okay, and the important thing to notice is now that this is not different. Although also green, like your data, it's now slightly different. If you compare it to your original data, you already see in the preview that it looks different, and the difference is actually that it's now not a grayscale image anymore like it was before with 8-bit unsigned and values between 0 and 255, but we now have actually a label image, which means in Avizo you have two different types of volumes. You have either grayscale volumes, which are have a continuous range of values that describe something, or label images which are supposed to be segmentation masks or label images that represent labels for certain structures. And you see that we only have two values in this label image now. We have 0 and 1. 0 is everything which is not blue here, and 1 is. So this is important also because now this label image is a different kind of data, meaning you will get different modules here. Most of them the same because this is pretty similar data, but some of them are probably different because this is a label image and not a regular volume image. Okay, so what we have is now a binary, what's called a binary image, an image that shows only rock and nothing else. You can now, for example, again try to visualize that the same way we did before. If you go now on make sure you select your new data here. So whatever you do will be done to whatever you have selected here, right? So let's select that and click the little triangle and go to display. So this is now label image. We could just volume render it again like we did before, but for label images, there's actually a nice module, new one, which is called voxelized rendering, which shows nicely, which is actually specially made for label volumes, because it shows what the label wanted to save it as slice, but not where's my slice? Oh, this is the interactive thresholding still. Right. So the interactive thresholding also has actually a display component. And this is now the voxelized rendering of our segmentation. It looks not so bad, but you see that we obviously got quite some noise down there. So our threshold was not perfect, but the rock looks nice. And why it's called voxelized rendering is if you zoom in a little bit, you see that it's now really just displaying one little cube for each voxel that is the object, and nothing if the voxel is not the object. So it looks like a little bit like this Lego. images that shows is just a binary image. So that's okay. It's not perfect. We get this noise here, but we can separate rock from not rock. But that's not all we want to do. We also want to, if you look at the slice again, we want to get this little tube around the rock, and we want to also identify the air around. So we don't only have one object in that volume, but we actually have in this case two, and often you might have many more, right? So what we can do to do also identify the others, you could now, like we did before, attach another interactive thresholding module here and do with different thresholds to get different structures. But there's actually a, let me turn that off. And let me turn that off. There's actually a nice module here which does that at once. So we go back again to image segmentation. We go to binarization. No, it's not in binarization because it's not binary anymore. It's actually here, multi-threshold. So if we do this multi-thresholding, again, we get another module here. So our project view is already filling up a little bit. That's something you have to get used to. The more things you do, it starts to get a mess here. So you always might want to move your module somewhere where that it stays somewhat clean. What you're doing. The multi-thresholding again is a red module, meaning it is a a compute module, so it will produce some data. And the way it does it, we can specify actually what kind of data or how many we have. So we just give labels or description of our different structures we have in the data here. By default, we have just two different objects in there, but we actually want to have three different, and I can just give them names like air, cube, and rock. And if I go out of this text box, you see that actually we got another widget here. Before there was just one, which was the separation between the two objects. Now we get two, so we get two boundaries between the one between the air and the tube, the boundary between air and tube, and one between the tube and the rock. And we can specify numbers here. So that's why we did the interactive thresholding before. We have seen if we do the interactive thresholding, I can actually quickly bring it up again. That it looked like that here this value of 33 nicely identified or approximately identified the rock. And if we move it down a little bit, we get more and more of the tube until we are 17 is nice. And if we go further down, we start getting air. So the separation between air and tube seems to be somewhere between around, let's say 17, right? Because now we have nothing is blue in the air, and we get the tube here, which is 17. And if we would go down to 33 here, we lose the rock inside. We also get some stuff inside, but we are missing the rock now. So the boundary between tube and rock, let's say somewhere between at 33, and between air and tube, it's somewhere at 17. So let's just put those in here. Turn off the interactive thresholding. 17 and 33. And let's just hit apply. What happens is, again, you don't see anything here because all that was done was it created a new module, a new data object actually. And if you look at it, you see it already in the preview that we now have actually three different objects: black, light blue, and dark blue. You see it also here in your data info. You still have a label image again, but it has now three different values: 0, 1, and 2. Okay, so we can try to look at that again in the same ways that we did before. We can attach an author slice. There's, by the way, in Avizo a nice way to reuse modules. You can just change the connection from one to the other. And if you do it right, it stays there, and it should show an author slice once you move. Interestingly, that did not work. Let's create a new one. Display and author slice. Great. There we go. There are a few useful buttons down here that just center your views. This is on the XY directions. That's what we want here now. Just press the button, it centers the views again on your object. Okay, so again, now we see it in big. What's the result of our multi-thresholding is just a rough segmentation of our object, of our data set now into air, which is black, into the tube, which is light blue, and into the rock, which is dark. And what you see is that it is not exactly perfect. Of course, for example, we missed some pixels here in the tube, right? These ones and these actually quite a lot. The rock looks okay, but there we actually have that. I don't know if that's a hole or not, but probably not. So we also missed a few pixels in there. So this kind of segmentation is quick and easy, but in most practical situations, it's actually not good enough. And the reason is essentially that most data is slightly noisy, and the values don't really represent the objects already themselves. And we'll have to do something more complex to do this classification in a smarter way. And that's what we're going to do in the next session. It's called the segmentation algorithm. It's called the watershed. And we'll do that right after the break. All right, welcome back, everybody. We're going to continue our short look at image segmentation techniques. We have done this simple thresholding, which allowed us to identify somewhat the air from the tube and from the rock. But we've seen, we still have it here. It's not really very good. We're missing some parts, some holes also here. And maybe we have a few things too much in here. The separation between air and tube seems to work nicely, but the tube and the rock themselves, not so. So we will have to use something more sophisticated. And the one thing we look at in this workshop is what's called watershed. And I'll just quickly demonstrate that. So again, turn off everything. We select our original data, that's what we want to segment, and we go to the image segmentation part. And you see that actually there are a few different watershed modules. We're just going to look at the at the simplest one, and this is just called watershed segmentation. Let's create that one. What happens is now we get a blue module. This is another type of module in Avizo, which means it's actually just a script that's being executed. And you see here actually the location where the script is. You could even take a look at the script. But this is one way to expand Avizo a little bit. And in this case, the watershed segmentation was just implemented like that. So what does a watershed actually do and mean? I'm not going to go into too much detail. Again, I want to point out that there is the help is very useful. Let's not talk on what you and on what how to use a certain module. So here again you get the description of all the widgets you have there, but also a little bit of explanation of what the watershed algorithm does. So you might want to look at this at some point. I'm just gonna present today how to use it actually, and maybe explain a little bit in quite intuitively only how it works. So, so the basic idea with the watershed is that you don't just threshold things, but you specify what's called markers. So let's say you would put markers around this tube or around here, just very roughly, and then you would put markers with different labels for the rocks down here, and then the watershed algorithm would just grow from those markers until it hits other labels, and that gets rid a little bit of the noise and works in a lot of situations quite nicely. So let's take a look at that. How this is actually implemented in this module, the watershed segmentation. This is actually a nice model. It guides you through the individual steps of the algorithm step by step. You see that actually, if you look here, you can always change the visualization between the different slices. Here you would actually have to change the display to see what's going on. I'll just stay in the XY slice for now. Zoom in a little. And you always have this info where it says at what step you are, and then the action to do. So the first thing we have to do is to specify how many faces we have. This is the term here for how many objects we want to identify in our volume. And let's say we could have any number, but we said before we want to essentially have air, tube, and rock, which is 3, and this is already there. We could put, if we had 5, we would put 5 here, but we have 3. We keep it by 3, and then we always have to hit this apply button to go to the next step. So here we are now at the next step. Let's make that doesn't help. The next step of the watershed algorithm is that's what it needs for it to work. And there's no detail given here. It has to compute the gradient magnitude of the image. There's nothing for us to do. All we can do here is hit apply. And that might take a few seconds depending on the size of your data set. Ours is rather small, so it's actually already finished. And you don't see anything because it just computed the gradient magnitude and keeps it, doesn't really display it. And you don't need to see it anyway. The next step of the threshold is of the algorithm is that it has a threshold gradient magnitude. Again, we cannot really do anything. So we just hit apply. And now we see that something happened. We have we see something, and we see also that the next step of our algorithm is to give a threshold for phase zero. Phase zero in our case, we cannot give any name here, but we assume it to be the air. So I call phase zero air. Phase one will be cube, and phase two will be rock. And as we've seen before, so you can actually interactively try to find it. So this is much too much, but we know the air starts at 0, and we've seen before that the cube starts at around 17. So we go definitely below 17. Let's put it in as a number here directly. But the good thing about the watershed algorithm is that we can be rather conservative. Yeah, all we want is a few markers inside the area which we call air. So I can actually go lower here. I can go to only 10, let's say. Then we see we start missing already parts in here, but that's in this case okay, because this is going to be filled by the watershed algorithm. So more important is that there is not much not in the what's supposed to be air. So let's try to go a bit lower even, only 5. That's probably too little because we want to have some stuff over here as well. So that's 8. Let's keep it at 8. That's good. We will have a few things here, but can try to repeat it afterwards and make it better. Let's stick with that the air is essentially the markers for the air. We want to use all the values that are between 0 and 8. So we hit apply. And then we are asked to give the threshold for the markers for phase 1, which is supposed to be the tube. By default, we already have now the 8, our threshold before, as a minimum value here, which is now actually too small. So we want to go somewhere around 17 for the tube, and somewhere below 33, which is the rock, right? But again, we can be rather conservative. We can make this smaller, actually rather smaller. 23 is probably good enough so that we don't hit any rock, but we still have thing inside the tube. And 17, maybe we can even increase it a little bit because we don't want to use any air. Let's try that. So actually, we can use a rather small threshold range here to just get the tube. We see that we have markers in the tube. There are a few in here which might make problems. Again, we will see that later, what the result is. So we hit apply to finish step 5 for phase 1, and there should be one more for step 6 for phase 2 now, which is the rock. We know that everything up to 255 will be rock, so we just have to kind of adjust this lower threshold, which we said before, 33 is rock, but we can again be a bit more conservative. Let's try 37 or something. You don't want to miss too much in this case because if you make it too high, you might miss small rocks in there. But that looks that maybe I can make it a bit more. 30. Let's see what this looks like. So these are now the markers for the rock. We hit apply here for finishing step 6. And step 7 is now simply compute the watershed. That's what we do. We hit apply. We see that let's see some progress bar here. It's actually pretty fast, and that's now the segmentation of our watershed algorithm. And you see that actually I can Avizo open the table view, which I don't need. I delete that. It's actually pretty decent that we have our air. The air seems pretty good. You can slice through it. So everything light blue is air. There's also some air in between, which is okay. It should even be more actually, because the tube should be only the ring. But we even have this air inside, and the rocks are also somewhat there, but it's probably not good enough. But but often this watershed algorithm gives nice results. Maybe this is good enough, maybe it's not. If it's not good enough, I would recommend that you look at our workshops that present more advanced techniques for doing this segmentation. Especially, we're gonna see the segmentation editor, which you could use here, and find out also AI techniques and deep learning, machine learning techniques for doing segmentation. Look at our webpage to find out about workshops and how to do that. All right. Now you could use the visualization techniques we've seen before to visualize your data nicely. Look, investigate your segmentation if it's what you want. If it's good enough, keep it. If not, use some more advanced techniques. This completes this workshop. Thank you for your attention, and please check out our other workshops and maybe see you there.